Hi, everyone. This is going to be our lecture video for the day that class was closed because of the weather. So hopefully I sound okay and I'm not as congested as I was last week. Last week was by far the worst I've ever felt in my life. And now we are experiencing what I think is probably the worst weather I've ever experienced in my life. So for me, it's been like a double whammy. But, anyways, I digress. Let's get to what we have to today. So, chapter two is all about uh organizing data. So let's go ahead and let's look at something real fast. On the board, you're going to see a table of data. Now, if you went ahead and you downloaded the lecture notes for this week, these are going to be the drive-through service time. So let me just write this out here for us. So drive-through service times in seconds at one of my favorite restaurants, McDonald's. I am a huge fan of fast food. I know it's not good for you. Excuse me. But that doesn't matter because regardless, it's delicious. And yeah. Anyways, so when we look at all this data collected here, now let's kind of recap some of the things that you should have learned in chapter one. Like, for example, the variable here would be the service times, right? So that's our variable. Okay, what type of variable is this? Well, because it's measured in seconds, this is a quantitative variable and it's continuous. All right. So we have our variable service times measured quantitatively, and it's a continuous type variable because it's time. What else here? I don't know anything about the sampling method. Okay, but the sampling method could have just been, let's say, convenient sampling. We drove up to the nearest McDonald's, we sat in the parking lot, and we had a stopwatch and said, okay, as soon as they place their order, we hit the stopwatch. As soon as they receive their bag of food and drive away, we end the stopwatch. And here are the times for those people, respectively. Now, a table of data is literally a table of data. It's not that good looking. Um, it's kind of cumbersome, and it really doesn't tell us anything. And you see, that is where what we're going to learn kicks in. So, what we're going to learn how to do right now is we're going to learn how to create a frequency distribution. All right. Now, what a frequency distribution does for us is it condenses all of the data. So, let me get rid of that circle. So, it condenses data into what we call bins. Now, there are other names other than bin, okay? Probably the most popular, and this is the one I'm going to be using, are going to be classes. So if you think about it, here's how a frequency distribution works, all right? You have these boxes or bins. So let's say we have 4 of them. We're just going to use this as an example. All right? And in the very first one, I'm going to throw all of the numbers that happen to fall in between, let's say 80 and 120 into the first bin. Then I'm going to throw all the numbers from 121 to, let's say, 150 into the next bin, 151 to, let's say, 180 to the third bin, and then 181 to like 210 to the last bin. And you would fall, or you would sort all of the data that you have into these bins. All right. And that's what a frequency distribution does. It just condenses the data for us. Now, by doing this, you kind of lose a little bit of the richness of the data. All right. But it gives you an idea of a bunch of things like what would be the average or what is the shape of this data and stuff like that. And you'll see what I mean here in a second. So, in order for us to do this properly, we got to know like a systematic technique to do this. All right. So I'm going to go ahead and I'm just going to scroll up here and we're going to go over some definitions on, all right, well, how do we do this? And then finally, using the data that I have, we will go ahead and create our frequency distribution for that data set. And it's very straightforward. Excuse me. There are definitely different ways to do this depending upon the data you have, depending upon the professor you have, even the book that you have. There's no there's no just like, hey, this is exactly how we do it across the world. That's not how this works. This is mainly like, hey, we're going to break down the data as quickly as we can to get an idea of the shape. Okay. If you're interested in other techniques on how to do this, just ask me and I'll show you. But they're pretty much all the same. It's, well, how do you, let's say, create the groups or something like that? All right. So, anyways, let's go ahead. So the first thing that I want to define is what we call the lower class limit. All right, now the lower class limit is going to be the smallest it's going to be the smallest number that can belong to each of the different classes. All right. So if I scroll up real quick, all right, and I get out my highlighter, the lower class limit is going to be 80 for the first bin, 121 for the second, 151 for the third, and then 181 for the fourth. These are all the lower class limits. All right. It's the first number that starts that specific class. Now, the next definition we have is going to be our upper class limit. Now, the upper class limit is going to be the largest number. That can belong to each of the different classes. All right. So again, if I get out my highlighter here, for the upper class limits, the first upper class limit is going to be 120. The next upper class limit is going to be 150. The third upper class limit 180, and then finally 210 for the last one. Okay, the next definition is going to be our class boundary. Now, the class boundary are numbers used to separate the classes, but without gaps created by limits. All right, so here's what we mean here, okay? So let's say in the first bin, I went from 80 to 120. And then in the second bin, I went from 121 to 150. Right here, 120.5, which is right in the middle. This would be my class boundary. Okay. Now, the class boundary really helps out in the next section when we are talking about creating a histogram. Okay. But for now, just know that it's just like a number that's in between the class bins. All right. That's really what it is. All right. Now we have our class midpoint. So these are values in the middle of each class. Excuse me. So when I was talking to you earlier about, when you have all this data right here, all right, and you start taking this data and then you start funneling it into each one of these bins that we have down here, right? So you lose some of the richness of the data. Well, what I meant by that is if there are numbers in between 80 and 120, once they go into that bin, I have no idea what those numbers are anymore. What I know is there is a specific count or frequency of those numbers between 80 and 120. I mean, you can have five 80s and one 120, but you would never know that because all you would know is you would have six total values between 80 and 120, five of them being 80, one of them being 120. Or you can have five of them being 80 and then one of them being 110. Again, you still have a frequency of six, but five of those numbers are 80 and then one of those numbers is 110. See, that's what we mean by you lose some of the richness of the data. You have no idea what those numbers are. You just know six numbers in your data set fell into that first bin. That's what I meant by you lose some of the richness of the data. Okay. We got one more definition here, and then we could start doing this. All right. So we did our class midpoint. Now we need our class width. All right. So the class width is the difference between two consecutive lower class limits or two upper class limits. All right. And here's basically all that we need. Not all of it. I said basically. Here's a couple other things, right? But here's what we're going to be using to actually go ahead and do a frequency distribution. Okay. So let's kind of just summarize here real quick. Frequency distributions. They summarize large data sets. Okay. Second, this is something I haven't mentioned, but you can identify potential outliers. Three, provides a basis for graphing. And four, and this is probably the most important, it'll identify the distribution type. Now, that should sound pretty foreign because we haven't really talked about distribution types at all. And we're going to a lot. So, what we mean by distribution type is like, okay, well, where the data fall, right? Or where or how. All right. To give you an idea, many of you know or at least heard of a bell-shaped curve. All right. So you've heard of a bell-shaped curve. This is a distribution type. We call it normal. But there are other types too. There is skewed right, skewed left. There's uniform. All right, and I'm gonna go over all of these when it's appropriate. I just kind of wanted to at least introduce you into them. All right, so you don't have to know the names of these, or in fact, let's just erase them. But that's what we mean by distribution type. Like, what is the shape of the data? Okay. So finally, the question now becomes, how do we do this? How do we actually, create a frequency distribution? What is our procedure? I'm just going to abbreviate it, frequency distribution. Okay. So step one. So what we always do first, select the number of classes. Traditionally, anywhere between 5 and 20. Now, on a test, I will tell you what I want it to be. I'll give it to you. I'll say, hey, let's all do this frequency distribution here, and please use 7 or 8 classes. All right. That way there's consistency. Like I said, this is exactly what you do every single time type scenario. All right. But normally it's between 5 and 20. Anytime I tell you to construct a frequency distribution, I will tell you the number of classes that I want. Step two, let's calculate our class width. So the class width is going to be the difference between the max value minus your minimum value, all divided by the number of classes. And you always, no matter what, you always round this number up. All right? Always round it up. All right? Excuse me. So step one, determine your number of classes. Step two, find your class width. Step three, choose a value for the first lower class limit. Now, traditionally, we just use our minimum value. Okay. Then from here, you're going to find each lower class limit for every class. Using the class width. All right. So I'll show you how to do that. Don't worry. All right. So step one, select the number of classes. Step two, calculate the class width. Step three, choose a value for the first lower class limit. Step four, I guess this would be step four, really. Let's go ahead. Let's fix that. Uh-oh. My mouse not working anymore? Oh, no, there it is. So there we go. Step 4, even though it's written in red, use the minimum value. Using the minimum value, find the next lower class limit by using the class width. Like I said, I'll show you how to do that. It's very, very simple. Okay. Step 5. Find the upper class limits. Now, if your data, if data are integers, meaning, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. No fractions, no decimals. Integers are not fractions. Integers are not decimals. So if the data are integers, subtract 1 from the second lower class limit. All right. So here's what we mean by this, okay? Let's say, for example, we have our first class, right? So classes frequency. All right. And let's say our first class started at 10 and the class width was 5. Okay. So if the first class starts at 10, then the next lower class limit would be 15, then 20, and 25, and so forth, right? Now, to find the upper class limits, what I'm going to do is I'm going to take this number right here. I'm going to take this 15, and I'm going to subtract 1 to it. So that's going to give me 14. And that's going to go right here. So then the next upper class limit is going to be 19. The next upper class limit would be 24. And then finally 29. And that's how we do this. All right. So if you think about it, the distance between this class limit and this class limit is a total of 5. The distance between the upper class and the next upper class is also 5. And then finally, the width is also 5. Because if you look at a number line, 10, 11, 12, 13, 14, right? This is our first value, second value, third value, fourth value, and fifth value. So it's also a class width of 5. So everything should work. Everything should work out perfectly. Okay? And that's how we do that. Excuse me. And then finally, step 6 is to just count. All right? So let's go ahead and let's do this with our data set that we have. So for me, I want to create a frequency distribution using 1, 2, 3, 4, 5, 6, 7, 8. Let's use 8 classes. All right. So remember, step 1, n equals 8. This is our number of classes. All right. Now, step 2, our class width. So the class width is going to equal our maximum value minus our minimum value divided by the number of classes. So if I scan the data here, all right, you're going to find, excuse me, you're going to find that the max value is 308 minus the minimum value is 83 all over 8, which is the number of classes. So that's going to equal 28.125. And we always round this number up. So our class width is going to be 29. All right. Next, step 3. All right. We're going to go ahead and we're going to do our classes. Now, I'm going to do this in a big table. All right. But I'll write down, the step that I'm doing. So find your lower class limit. All right. So let's see what's the prettiest way I could do this here. All right. You know what? I don't think there is a pretty way. So we're just going to do it. So the lower class, the first one is going to be 83. All right. So that's like class number 1. I don't like that at all. We're just going to leave it like that. All right. Now, step 4 says to find everything else. All right. So find excuse me. So we're going to find all the lower limits, then all the upper limits. Okay. So let's go ahead. Let's do that. So here, remember, here's how we do this. And a calculator really, really helps. So we have our classes. You know what? Let's do this. I'm just going to copy and paste our data set again. So we have our classes. We have our frequency count. Because eventually we're just going to get to counting. Might as well just start setting this up. All right, so the first class is 83. Then we got to find all the lower class limits. So 83 plus 29. Excuse me, is 112. Now we're going to add 29 again. 141. And we do this 8 times. All right, because we need 8 classes. So 141 and then 170. 199. 228. 257. And 286. All right, hopefully my math is correct. So there's all the lower class limits. Now let's go ahead and let's do all the upper class limits. So we know the first one is 83, and then the next class is 112. Well, it has to end at 111, which is 1 less, exactly what we would expect. So we have 111 plus 29 is 140, which is 1 less than 141. Then we have 140 plus 29, which is 169, which is 1 less than 170, and so forth. So let's go ahead. Let's just keep doing this. So plus 29, 198. Oops, that's a terrible looking 8. 227. 256. 285. And finally, 314. Excuse me. All right, so there's step 4. Is it step 4? Yeah. Find all the lower, then find all the upper class limits. All right. Step 5. This will come under here. Count. All right, so I went ahead and already counted all this for you because otherwise we would just be wasting time. So the number of values that fall in between 83 and 111 is 6. The number of values that fall in between 112 and 140, we have 13. The number of values between 141 and 169 is 15. And if I just fill it out, it's going to be 8, 3, 3, 1, and 1. And congratulations, we just completed our first frequency distribution. So the table of data that I have here breaks down into this. Now I can sit here and start really making some I could really start to make some guesses, educated guesses about the drive-through times at this McDonald's. Like for example, it looks like the majority of time that somebody will be spent in the drive-through is right here in between those times right there. All right? Now it doesn't tell me exactly what it is, and that's fine. But what I know is that's the majority of the data. That's where it lies right there. All right? If I were to like draw a graph of this graph would look something like this. Look something like that. All right, which is not exactly a bell-shaped curve. And I'll show you how I get this, later, but that's what it would look like. All right? So, if we wanted to, we could go ahead and take this one step further. All right? A lot of the times after you create a frequency count, sometimes we want a relative frequency distribution. All right? Now, a relative frequency distribution is very simple to get. So, the relative frequency is equal to the frequency count for each class divided by the sum total frequency. All right. So, in other words, we just take the frequency count for each class and we divide it by the total number of frequencies that we have. If you wanted a percent, or percentage relative frequency, you take the relative frequency and multiply it by 100. That's it. I'll do both for us here. So the first thing we're going to do, excuse me, we're going to count up the total number of frequencies that we have. So 6 plus 13 plus 15 plus 8 plus 3 plus 3 plus 1 is 50. All right. Or you could have just said, well, this is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a 5 by 10 rectangle, and to find the area of a rectangle, it's length times width. So 50 data values as well. So that's just a shortcut way. So we know the sum total is going to be 50. So all I have to do, and I'm going to zoom in for us here. So bear with me. So for the first one, this is just going to be 60 divided by 50, which is 0.12. Then we have 13 divided by 50, which is 0.26. 15 divided by 50, 0.3. 8 divided by 50, 0.16. 3 divided by 50, 0.06, and 0.06 again. And then 1 divided by 50, 0.02. So there is our relative frequency distribution, our percentage, 12%, 26%, 30%, 16%, 6%, 6%, 2%, and 2%. So it's very simple. Okay. And that's going to be it for this section. So the idea is to take a lump of data and break it down into something that's meaningful for the average person to look at. That's really what we're doing here. So I hope this helped, and I'll see you in the next video.